Okay, my apologies, grade 11s. The video cut out while I was doing the example at the end of the last video. So I'm just going to go a little bit back and then continue where I left off. Okay, so remember they had given you this drawing and then said determine x and y. So with x, we already established that that is double the size of 30 because angle at the center is double the size of the angle at the circumference. So then x would be 60, and we can write that in here, 60. Okay, so what we still need to do is calculate y, and obviously we're doing the tan chord theorem, so we're going to most likely be working with that over here. And I see a triangle attached to the tangent here, so it rings the bell that it must be that tan chord theorem. Okay, so remember what you're going to do is count. You use your 1, 2, 3, 4 method. It really does help assist with that. So I'm looking at this y over here. So obviously I'm coming from this side, 1, 2. There's no use me coming from this side because 1, 2 or 1, 2 is just going to give me these angles here. I'm looking at this y angle. So I'm going to count and I'm going to make sure I form that angle that they are asking for. So it's 1, right? 2. Do you see? I'm ensuring that I make that angle. So 1, 2, and 2 is going to take me to the circumference. So 1, 2, then I go 3, 4. Do you see? 1, 2, 3, 4. So once I get to 2, which is on the circumference, I go to another point on the circumference and I go back to where I started. 1, 2, 3, 4. Does that make sense? Okay, 1, 2, 3, 4. And remember, 1 and 3 is what you are, is the same angle. So over here, this angle between 1 and 2 is the one the tan chord forms. So 1, 2, 3 and 4 is what's going to create our other angle. So here is 3, 4. 1, 2, 3 always lands on 3, 4. So you're looking at 1 and 3. Okay, so we know that those two are the angles that are equal to each other. Okay, so I think there was actually labeling here. My apologies, I didn't write this in nicely. Just find the page that I got this example from. I just need to make sure I label it. Okay, so this was A, C, B, that's O, and that's D, and that's E. Okay, sorry, that makes it, and they call this A1 and C1. All right, so I know that angle Y is equal to this whole angle, right? So it's going to be 15 plus angle A1. I know it's those two added together, and why do I know that? You can either say tan chord theorem or you can say angle between tan and chord. I mean, I like using the tan chord theorem reason. I think it's just so stuck in my head. But either one you're allowed to use as your reason. Okay, so now I obviously need to go and find out what A1 is. And what I want you to notice here is that there is a triangle, and it is very clearly an isosceles triangle because this and that side are equal to each other. So obviously if those two sides are equal, we know base angle. So that side or that angle must equal that angle. And we did an example in the previous video of what you do with that. If you have an isosceles triangle and they say that's 60, clearly these two angles are going to be 180 minus that 60, right? Because then it's what's left, and you divide that by 2. It gives you the two angles there. So that's what I'm going to do here. I'm going to say angle A1 is equal to 180 minus 60 over 2, right? Which is equal to 60 degrees. It's 120 over 2, which is 60. But I must ensure that I put a reason there. There's actually two reasons we used. The one was base angles of an isosceles triangle, and the second reason is sum angles of a triangle. Okay, sorry, let's put that there. So obviously the one, you have to have base angles because to divide it by 2, we're assuming that they're the same, and we're also using sum angles of triangle because we're saying that they add up to 180 degrees. All right, I hope that makes sense. Fairly simple example. The important thing from this video is that I want you to know how the 1, 2, 3, 4 works. Okay, got another example 2 here for you guys. Okay, this one's a little bit more complicated, and I'm actually glad that I had to do this part of the video again, because the way that I had it before, it might still go that way, but there were so many colors on here, even I was getting confused. Okay, but we are trying to calculate V, W, X, Y, and Z. So it's quite a long one. There's 5 different letters. Before I even begin, I want to establish and make sure that you realize that AC is not a diameter. They have not put a point in the center saying that that's the origin, so you can't say that AC is a diameter, and they haven't told you that it's a diameter. Because you may have been tempted to say that X is 90, because diameters always subtend 90, and then your reason for that would be angles in a semicircle. However, we don't know that AC is the diameter, so you cannot do that. Okay, the first thing that I see, I think X is a very easy one to do, because clearly this is a triangle. We know 50 and we know 30, so I think X would be easy to use, some angles of a triangle. So I'm going to go ahead and say 180 minus 50 degrees minus 30 degrees, because some angles of a triangle. Okay, so X is then going to be equal to 100 degrees. All right, and when you work something out, go and put it in, because it does make your life a bit easier. So that is 100. Okay, the next thing we can maybe do, let's just do it in alphabetical. I suppose I've left out the V and the W, but let's do Y next after X. And clearly it's attached to the tangent, and there's a triangle going on here. So my brain would flash that you should use the tan chord theorem, because it's got that 1, 2, 3, 4 movement that you can do. So let's use the same color just to help ourselves. So I'm looking for Y, okay? I'm going to do, when I do the 1, 2, 3, 4, I go towards and I make the angle that I'm looking at. So your angle 1, 2 must be that angle that they're asking about. So 1, 2, then to the other point, 3, other point of the circumference, and 4. Are you with me? So remember, 1 and 3 is what you're looking for. 1, 2, 3, 4. So this should be the same as Y. So I can now go and say Y is equal to what? 30 degrees, because tan chord theorem. All right. Okay, so I hope you understand where this 30 now comes from. 1, 2. Make that angle between your tangent and your chord. 1, 2, 3, 4. 1 and 3 are always going to be the same. That's why I say count, so you can see it. It will be easier for you to see. All right. Okay, so now we've got Y. Let's go do, look, like I said, there's going to be a lot of tan chords going on here, but let's move on to W over there, because my brain can already see a tan chord theorem. And even though W, it's not the angle by the tangent, but it corresponds with this 30 here. And you can kind of see it, right? You can kind of see 1, 2, 3, 4. Okay, so let's use our light blue and do that. So it's going to be 1, 2. I'm making it because I want this 30. This is actually the answer here. So 1, 2, 3, and 4. Do you see with this 1, 2, 3, 4 shape that W is the third one and this 30 is the first one? So the W and the third correspond. 1, 2, 3, 4. Okay, so W is equal to 30 degrees again, and you can just write it over tan chord theorem. I don't feel like writing it again. So this W is now 30. All right, so let's go on now to what's next. Let's do V. Let's see if there's any tan chord theorems for this one. See, even for me, it's not always obvious. You have to really think about it, and that's the point. Okay, I do see a tan chord theorem, but it's a little bit of a tricky one to see because you see, you want V to land up being the third one. It's not one of the ones here, but it's got to be the third one. So if I count here, watch this. 1, 2, 3, 4. Are you with me? Do you see how I did that? And be careful because you could go in different directions. If I said 1, 2, 3, 4, 30 would be 3. But if I do this bigger angle, I go 1, 2. Now from here, the next point that I could go is 3 and back to where I started. 1, 2, 3, 4. So this whole angle here is going to correspond with V. So let's just draw it in, maybe it'll help you. 1, 2, 3, 4. Okay, so now this whole thing is going to correspond with that whole thing. I know it's confusing. So V is going to be, okay, but remember this isn't just 50 and it's both of these added together. So it's 50 plus 30, which is going to give me 80. So V is 80. And your reason again is your tan chord theorem. See, this is why I said just now when I did this and it didn't record, it was looking like a rainbow because it got so complicated with the different colors. Okay, so we've got Y, we've got X, we've got W, we've got V. All that's left is Z. Z being this whole thing. Is your brain ringing? Look at how we just did this one. 1, 2, 3, 4. Is your brain ringing this bell of the tan chord theorem? I'd actually like you to pause the video here and see if you can see the tan chord theorem. But really, it's almost like a mirror image of how we did this tan chord theorem. So give it a pause, see if you can figure it out. All right. So this one, obviously Z is this whole angle. So this is going to be my 1, 2, right? 1, 2. Okay, because I want this 30 over here. So 1, 2, 3. Sorry, not the 30, the Z. 1, 2, 3, 4. And I don't think I actually explained this properly before, but if you were tempted to go 1, 2, 3, 4, you're never going to go back towards the side that you were on. It goes in the opposite direction. So 1, 2, this way, 3, 4. Okay, so Z clearly, this one over here, this whole Z, corresponds with this X over here, this 100. We already established it is 100. 1, 2, 3. This is the third one. So 1 and 3 must go together. So Z is equal to 100, again because tan chord theorem. Okay, I just want to re-explain what I meant about it goes in the opposite direction. Okay, so look here. Okay, when you're doing tan chord theorem, okay, you count. You go 1, 2, and then do you see that it doesn't go this way, it goes this way. 3, 4. This was from the simple examples. So those two went together. But sometimes you get something like this. So I'm just going to redraw this. So I can go over it one more time to show you what I mean. If I'm looking for this angle over here, okay, or let's just say, yeah. So if I'm looking for that angle over there, it's easy, right? It's 1, 2, and the only direction I can go is 3, 4. But if I'm looking at this bigger one over here, and I go 1, 2, okay, now I'm here. Do you see there's a chord this way and there's a chord that way? It could go, it feels like it could go either ways because both sides are to the circumference, but you're always going to go away. Okay, it's almost like you're making a Z. You want it to go away from the side you were just at, and then it goes back. So 1, 2, 3, 4. So this, oh sorry, 1, 2, 3. Here's 3. So 3 and 1 would go together. But don't go 1, 2, 3, 4. It's not this and this. Okay? Just make sure you go in the opposite direction. Anyways, I hope these examples make sense. The next video will be on exam questions.